Secant and cosecant. We'll start with the cosecant curve. Y equals cosecant of x. All right. Now, what's cosecant the reciprocal of? Sine.
I need all the males that are in mixed choir in the auditorium right now. Thank you.
Ooh. Ooh.
All the males in mixed choir.
In the auditorium right now.
It's so annoying.
Ooh,
Yeah. It's a handful.
And he did not sound happy.
He did not sound happy.
Nothing happened particularly today other than one of the guys has spilled their gum, but we've been having problems the past couple days. So.
All right. So let's think of what sine is first. So x sine of x. And then we're going to look at cosecant of x. And we'll see how they're all related to each other. Just relax. So if x is 0, what's the sine of 0 pi? 0. Okay. Now, what's the reciprocal of 0? No.
Doesn't exist.
Undefined.
Yeah, I got it right.
Okay.
Those are the two that we don't need to worry about, though.
Pi over 4. What's the sine of pi over 4? Square root of 2 over 2. What's the reciprocal of the square root of 2 over 2? Let's just give me a decimal answer to that. What's 2 divided by square root of 2? Somebody with a calculadora, por favor. 2 divided by... What?
You said 2 divided by square root of 2.
2 divided by square root of 2. 1 point.
What? Something happened to me.
2 divided by the square root of 2.
I don't know. Mr. Birchbach, I got lots of papers. What are the chances that we could erase what's there?
What do we got?
Well, what happened to my calculator?
1.4?
Oh, she doesn't know. Wait, 2 square root of 2?
No.
Because my calculator.
1 or no, it's 2 divided by the square root of 2.
I got it. 1.414.
1.4 approximately. Good enough. Whoo! That was hard enough.
No, my calculator's not broken.
Okay. Pi over 2. What's the sine of pi over 2? 1.
1.
So what's the reciprocal of 1? 1. 3 pi over 4 is square root of 2 over 2, which gives me 1.4 here. Pi. What's the sign at pi? 0. What's the reciprocal of 0? Undefined.
What is that? Is that a 2? No, that's
Let's go 5 pi over 4 now. Well, the sign is negative square root of 2 over 2. So then the reciprocal would be negative 1.4. 3 pi over 2. What's the sign of 3 pi over 2? I'm going Mach 10 here. I need to slow down to less than the speed of sound, is what you're saying? Okay. So 3 pi over 2 gives us the sign of equals, the sign of 3 pi over 2 is negative 1. What's reciprocal of negative 1? Negative 1. Last two. 7 pi over 4 and 2 pi. There. Zoomed in.
Thank you.
7 pi over 4 is again negative square root of 2 over 2. Which is again negative 1.4. And 2 pi is 0, which is nope. It's not 0. So let's graph these two functions.
How was that? You got yelled at?
Freshman, yeah, typical.
Yeah.
Like really dumb.
No one likes.
Oh, like really dumb.
Yeah, like really dumb, really.
Do you care to
Sexual
explain?
harassment.
Oh yeah, I had a top.
Hooray.
Yeah.
All right, so let's graph the sine curve in red. 0, 1, 0, negative 1, 0.
Okay, wait, what's going on?
This is a sine curve. This is what we've been doing for the last 2 class periods, or 4 class periods probably. The normal sine curve.
I'm not even like done with the graph. Don't forget to text on. Yeah. Wow, I really.
Now, in light blue, I'm going to graph cosecant. If something is undefined, it's not graphed, right? So then at pi over 4, I'm going to be at like 1.4, which is about right there-ish.
I don't know.
Wait,
Oh,
where is this line?
Where is it? Oh, there. Or the blue dot. Sorry.
The light blue dot.
We turn off the back first.
Yeah, we can turn off the front lights.
Yeah.
That switch right there. Okay, at pi over 2, it's 1. 3 pi over 4, it's 1.4 again. So it kind of looks like this, right?
Yep.
A little bit of a smiley face. But then we got to figure out what happens somewhere in between there. As this gets smaller, like somewhere over here, this is 1/2. What's the reciprocal of 1/2? 2. So where this is 1/2, this is like 2. So, and then this keeps going up and up and up and up and up and up, right? Kind of like a parabola, right?
Oh. Parabola.
I said if this is 1/2, if the red curve is 1/2, wherever the red curve is 1/2, the blue curve will be the reciprocal of that. The reciprocal of 1/2 is 2, right? So these are just reciprocals. So the smaller the red gets, the bigger the blue gets. Where the red curve is 1/2, right there. Okay. Where this curve hits 1/2, a y value of 1/2. What's the reciprocal of 1/2? 2. So where this hits 1/4, what's the reciprocal of 1/4? 4, somewhere up here. Where this is 1/6, what's the reciprocal of 1/6? 6, and so on. So as this gets smaller, as the red gets smaller, the blue gets bigger and bigger and bigger. So big, but it cannot be here. So it gets really close to here, but it can't be here. What is formed when you get really, really close? Algebra 2 people, come on, you're talking about this right now. Starts with an A. asymptote. So we have a vertical asymptote where we are undefined. Vertical asymptote where we are undefined. So a vertical asymptote where we are undefined. So we have a curve where it's positive, and then we'll have a curve down here where it's negative. So, do you need to be exact with these? No, but you can't go like this. That doesn't work. I count points off on the test if you go like that. So just make a nice looking curve where it gets close to the line. Nice looking the parabola. Not just like that. That's bad. That doesn't get you points on the test. Okay. Now, do you understand the concept of this? Because of reciprocals. Okay. Now let's do secant now. Yeah. Okay. So here we go. Now we're going to graph y equals secant of x. We'll go with this. We're going to graph y equals secant of x. Secant of x is a reciprocal of what function? Cosine. So we're going to do kind of the same process here. And because we have some people that just aren't grasping this totally, we'll go through the same process so we kind of try to get it down. I didn't call anybody out.
I was gonna say.
All right. So, x, the reciprocal is a cosine of x. Then we have the secant of x. You will not have to write out XY charts for these. Okay? After we do enough of these, you'll get the concept and it won't be that bad. So it's 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. You need toast? Yeah.
Yes.
Why? Did you take medicine this morning and now it's making your stomach upset?
I can't handle broth. I gotta run. I'm not gonna go.
All right. What's cosine at 0 radians and 0 degrees? 1. So I'm going to do cosine in green. How about we do green? So cosine is 1 there. What's cosine of pi over 4? Square root of 2 over 2. What's cosine at pi over 2? Cosine is 0 at pi over 2. Because it's the top of your unit circle. So sine is 1, cosine 0. 3 pi over 4. What's cosine? Negative square root of 2 over 2. What's cosine at pi? Negative 1. How about 5 pi over 4? Negative square root of 2 over 2. 3 pi over 2. 0. 7 pi over 4. Square root of 2 over 2. And 2 pi. 1. That green's hard to read? We'll move it over a little bit. Maybe orange will be easier to read. Okay, what's the reciprocal of 1? 1. What's the reciprocal of square root of 2 over 2? 1.4. What's the reciprocal of 0? Undefined. Woo. What's the reciprocal of negative square root of 2 over 2? Negative 1.4. The reciprocal of negative 1? Negative 1. Wow.
You don't have any more? Oh, dang. That's bad.
All right. At 5 pi over 4, where should we be? Negative 1.4. At 3 pi over 2, we should be at? Undefined. Then 1.4. Then 1. So, in green, I'm going to graph my cosine curve. 1. Jeez, language. All right. 0. 0.70. Boom. The normal cosine curve, which we've been doing for like 4 class periods now. I just put in an extra dots because that's where square root of 2 over 2 is like 0.7071. So, I'm sorry. Now, should I put in any asymptotes anywhere?
Why?
Sure, I should put in asymptotes. Where should I put them? Where it's undefined. Where is it undefined? Where's secant undefined at? At pi over 2. And at 3 pi over 2. So, in orange, at 0, I'm at 1. At pi over 2, I'm at 1.4. And what do you think as I get closer to pi over 2, what's going to happen? Going to go up or down? If I'm here and I go to here, what's going to happen? I'm going to go up. And it's going to be asymptotic with that dashed line. I'm going to get close and close to that dashed line. Never going to touch it.
Because somehow that makes sense.
All right. At pi, I'm going to be at negative 1. 3 pi over 4 and 5 pi over 4, I'm going to be at negative 1.4. Okay. Then at 2 pi, I'm at 1. I'm 1.4 here, and I go like this. Now, to make you mad.
Ooh, thank you. I can't wait.
Mr. Bierschbach doesn't like half parabolas graphed. So since Mr. Bierschbach doesn't like half parabolas graphed, 1, 2, 3, 4, we are going to continue on with our pattern. So we're going to continue on with the cosine because it must go like this yet, right? And where it hits the x-axis, what's going to happen? And so then you're going to have an asymptote, right? So we're going to have an asymptote right here. And what are we going to do with our parabola? It's going to finish going up. And now I have two parabolas, two whole parabolas, which is what I want to see. Now, could have I done that over on the left side? Yep, I sure could have. I could have gone over 4 this way, made an asymptote, made an orange thingy go up like this. Okay?
Why did you do one side versus?
It doesn't matter.
Do we have to do?
No, it doesn't matter which side you do, but I want one whole parabola, either one place or the other. Okay? What? Okay, now, we aren't just graphing secant and cosecant because, that would just be too easy.
Yeah, obviously.
So we could graph y equals like a cosecant of b times x minus c plus d, couldn't we?
Sure. Yes.
We could, but we're probably not going to get that far into it. Okay? So let's graph this. Let's graph y equals -2 cosecant of x minus pi over 4. Let's graph that one once. Not soon enough for some of you.
No, that's not why.
Lunch is not next. No. We got one more period before lunch. All right. So the cosecant is a reciprocal of what function? Sine. Notice how I have a 4 here. So pi must be either 4 squares over or a multiple of 4 squares over. So I'm going to make it a multiple of 4 squares over. So I'm going to make pi over 2 4 squares and pi 8 squares. And then I'm going to go 1, 2, 3, -1, -2, -3. All right. Now, this is where we really need lots of colors. So hopefully by now you've brought different colored pens and pencils and stuff. All right, so we'll start with a green and just graph y equals sine of x, because the sine is a reciprocal of the cosecant function. So what's y equals sine of x? Well, it's 0, 1, 0, -1, 0. If you don't know where to graph y equals sine of x yet, you are like way behind. You are 4 class periods behind. Yeah. So we should know what y equals sine of x is. Now, I'm not going to change that into cosecant yet. Nope. We're going to stay with sine, and we're going to graph y equals -2 sine of x. We're going to graph y equals -2 sine of x. So what happens there? Do I move 2 to the left?
No, it flips off the x-axis.
Reflect it around the x-axis and go twice as low and twice as high. So I start out at 0. Instead of being at 1, I'm going to be at -2. I'm going to go back to 0. Instead of being at -1, I'm at a +2 and back. All right. Now, should I put it on my cosine curve? No, we should not do that yet. Next, I need to move. What do I need to move? Well, I need to move right by pi over 4. So y equals negative 2 sine of x minus pi over 4. So my purple one goes to the right, pi over 4, which is how many squares? Two squares on mine. Everything goes 2 squares to the right. And then I'm going to put in asymptotes. Where should I put my asymptotes? Well, it's where the last graph, the red graph, hits the x-axis. Boom, 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 boom. Boom, 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 boom. Boom, 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 boom. What do you think my last step is?
Drawing all them squiggles.
Drawing all those squigglies. Yeah.
Draw a parabola from the red, because that was the last one here. Draw a parabola down. And it doesn't have to be exact. You just want to get close to the asymptotes. And then from here, from the red, draw a parabola up. And that's what I'm looking for. I have 2 parabolas. That's all I need. Let's do one more, and I'm going to call it good for the day. So now what I'm going to graph is y equals the secant of 2x. What does a 2 affect? The period. Thank you, Oliver. It affects the period. So since that's a 2, I'll just go 4 again to get to pi over 2, pi, 3 pi over 2, and 2 pi, and 1, and 2, and negative 1, and negative 2. All right. So let's graph y equals cosine of x first. Where does cosine of x start? 0, 1. And then pi over 2, 0. Pi negative 1. 3 pi over 2, 0. 2 pi, 1. All right. We're just extended it out so we can get our full parabolas in. All right. Now, what does